Hey guys, and welcome back to a new video. You've probably noticed that in the past weeks, I've uploaded some videos on backend development, specifically with Spring Boot and Kotlin. And since most of my current followers on this channel are probably native Android developers focused on Kotlin as a programming language, a very common question I got from you regarding these backend topics is, should you actually use Spring Boot with Kotlin or should you use Ktor? Ktor, you maybe know this from the Ktor client library on Android, which you can use to make HTTP requests. But the same way, Ktor is also a server-based framework. So we can write our own backend code, our own server infrastructure in Kotlin. In this video, I will really compare those two backend frameworks, Spring Boot versus Ktor, in 4 categories, specifically in the core differences of these two frameworks, in their maturity, the ease of use, and my own personal experience with them. So if you're currently saying you know Kotlin and you're on the fence about whether you should learn backend development with Spring Boot or with Ktor, this video will help you out. So let's first of all understand the core differences of these two frameworks. Spring Boot, on the one hand, is a Java-based backend framework that we can still develop for in Kotlin. So as you maybe know, Java and Kotlin are fully interoperable. That means if we have a Java project, we can still write certain parts of that in Kotlin. If we have a Java project, we can still add Kotlin libraries. And if we have a Kotlin project, we can add Java libraries. So while most Spring Boot developers will probably use Java at the current time because Java is way more spread on the market, it's still perfectly viable and doable to write Kotlin code for it, which I've shown you exactly in my recent 3-hour crash course. Ktor, on the other hand, is a Kotlin-first backend framework. So that means the backend code itself, the backend framework itself, was fully written in Kotlin. And what this specifically means, I will talk a bit more about when I talk about ease of use and how enjoyable each framework is. But it's already important to mention, whatever of these you pick, whether you pick Spring Boot with Kotlin or Ktor with Kotlin, both these are currently niche frameworks. Spring Boot itself is not a niche framework, but Spring Boot with Kotlin is. And this does in no way mean that Spring Boot with Kotlin is bad or that Ktor is bad. But of course, an important aspect of how valuable a technology is in the industry is how many people can work with that technology. If you know the best backend framework in the world, with the best programming language in the world, this is not valuable to a company if it's only you knowing that, and if they wouldn't find any employees just being good at that technology and helping to develop that backend. And right now, as I said, there are just way more Java developers developing for Spring Boot, developing Spring Boot backends, than there are Kotlin developers. Since Kotlin, after all, is mainly popular in the Android KMP bubble, but outside of that, Kotlin is currently not much adopted. So that to be said, if you are serious about backend development, you say, this is something I want to make my career, then I would definitely consider using Java for Spring Boot if you enjoy Spring Boot itself as a framework, or just taking a look at other popular backend frameworks like Node.js, for example. However, if you are a native Android developer and you say backend development is a completely new thing for you, then I would start with Kotlin, because you don't need to learn a whole new programming language in order to start building your first backend. If you already know Kotlin, you can stick to Spring Boot, you can stick to Ktor, and both of these will just work fine in order to teach you the backend fundamentals. And at some point, if you say, okay, now I really want to make this a career, then you can say, okay, now I just learned a new programming language, but I already know I have these basics already of backend development, and you just then have to learn the new language and apply that to the concepts you already know from Spring Boot, for example, itself, after you've learned Java or so. And maybe you already know Java. Let's next talk about the maturity of those backend frameworks. This point, I must say, clearly goes to Spring Boot. Since Spring Boot is based on the so-called Spring framework, that is where the name comes from, and the Spring framework is really just a set of Java enterprise libraries, so lots of very mature libraries and frameworks, lots of different use cases. For example, security. In the Spring Boot crash course, we've made use of Spring Security, which helps us to, for example, hash passwords, to encrypt certain stuff, and so on. But this is really just one example of the entire Spring framework. So there is a huge amount of helpful libraries, of very mature libraries available for Spring Boot that you can directly make use of, since this Spring framework, so the set of libraries, consists since 2003. Spring Boot, on the other hand, is just the backend framework that is based on these libraries. Spring Boot exists since, I think, 2013 and 14 or so. But it makes use of all those helpful libraries in the Spring framework. Ktor, on the other hand, at least according to their GitHub repository, was first released in 2018, so 5 years after Spring Boot was released. So this is one thing. Spring Boot has a 5-year advantage over Ktor if you really just take a look at the backend framework itself. But we also need to consider that Kotlin as a programming language is a much, much fresher programming language than Java. Java is also an ancient programming language, kind of, and that means there was a much longer time period, where people could write, for example, libraries for Java applications in Java, because Java just exists for much longer. And again, a great example is the Spring framework, which is just a set of libraries written in Java. And it's of course a big advantage if Spring Boot launches in 2013 or so and can immediately make use of all those super helpful libraries, compared to Ktor, which is a Kotlin first framework, which therefore also relies on pure Kotlin libraries, so libraries written just in Kotlin without any Java part. Since if Kotlin simply did not exist for that long as Java, then Ktor also did not have the chance to actually access this large pool of existing Kotlin-only libraries. So again, without saying that one of these backends is definitely the superior one, what we can say is that Spring Boot is certainly the more mature one. And if you are looking to make a career in backend development, then looking for mature options that are just broadly used in the industry is, of course, what is usually the smarter option for you. So this point clearly goes to Spring Boot. Let's next talk about the ease of use. So how is the development experience actually like? And here I actually want to also compare two sample code bases, one in Spring Boot, one with Ktor, and just compare very prominent aspects of what most backend frameworks consist of. But first of all, I have to say, if you like Kotlin as a language and you like the language features that Kotlin brings, you will probably have a bit more enjoyment with Ktor, because as I said, Ktor is Kotlin only, it's Kotlin first. That means the entire framework was built in Kotlin code, and we can fully make use of all those cool Kotlin language features that we love. So that means in Ktor you have full support for null safety, which is something that we only have in Kotlin. In Java, we can have all those null pointer exceptions. And even if we write our Spring Boot application in Kotlin, that still means if certain code is coming from a library that was written in Java, these null pointer exceptions can still happen unless we also work with these null operators from Kotlin. But it's still a little bit nicer to really work with this pure null safety that directly comes from Kotlin. Then in Ktor, everything is coroutine based. Coroutines are a concept that we have in Kotlin, but not directly in Java. And they just make it very intuitive when we work with asynchronous calls. And on a backend framework, in a backend environment, we of course have to work with a lot of asynchronous calls. Because you must imagine this is one single program which runs on some kind of remote machine, and lots of different clients can send requests to this remote machine at the same time. So we definitely need asynchronous programming there. We definitely need a way to have these blocking calls in a way that they don't block each other, that we can execute and handle certain requests at the same time in parallel. And Kotlin's kind of native way to do that is with coroutines, which make this very intuitive, way more intuitive, by the way, than threads, which is the typical way how Java handles this. And in general, in Kotlin, we just have this typical Kotlin idiomatic approach of defining the server config, of retrieving certain HTTP requests we then handle in our Ktor code, and so on. But I really want to show you some code so you get an impression of how it's really like to develop for these two types of backends. Here I am in this code base for my Spring Boot crash course. Again, you can find this on my YouTube channel. Just 2 weeks ago or so I launched this. And let's first of all take a look at probably the most important thing a backend has to do, and that is receive and handle requests from clients. So typically REST requests, HTTP requests or so, but could of course also be like a WebSocket connection or something like that. Here, for example, we have our node controller. This is how this works in Spring Boot. So it works with these REST controllers, which define functions that would be called if we actually make an HTTP call to a specific route, like here, for example, HTTP to our URL /nodes, so to the nodes endpoint. This is what we define here with annotations in Spring Boot. And if we would make a post request to this /nodes endpoint, the REST controller would take a look. Okay, this is the one responsible. It then takes a look. Oh, okay, here we have this post mapping. So the save function would be executed. We would get the owner ID. We would create a node. We would save it in our remote database. Here in this example, I'm using Mongo Atlas. And then we would simply return the node. So the node that was saved in the DB. And we convert it to our node response. And this response will then automatically be converted to JSON from Spring Boot. So all that happens on the node. We don't need to set up anything for that. This will work out of the box And this is pretty much how Spring Boot receives and handles a request. If on Spring Boot we want to respond with custom status codes, so every HTTP call has a specific status code as the response, so whether everything was successful, whether there was a client-side error, whether the user lacks authentication details or so. So a big part of that Spring Boot already handles naturally. But if we want to, for example, say, hey, something went wrong, then this works via exceptions in Spring Boot. So we can throw these response status exceptions, and then we can say HTTP status dot conflict, for example, which would be 409. And then at the point where we throw this exception, Spring Boot would interrupt this save call or this save endpoint and respond with this conflict status code, showing to the client that something went wrong. You can also see that here nothing is really coroutine-based on Spring Boot, since again, it's a Java-based framework, so we need to work with the limitations Java has. So none of these functions here are suspending in any way, but Spring Boot obviously handles this for us, that these requests are still being handled in parallel, of course, that separate threads will be started. All that complexity is abstracted from us away. If we take a look at the Ktor side of things, and this is now not the same backend in Ktor, but it's my unique backend for my running tracker app, which I have the Android Essentials bundle course about, where we build a backend for a running tracker app, where we can save those runs for specific users remotely. I've never shared this backend code before, and I also would prefer not diving into all the details, but I am happy to share some classes here just to show you how certain parts from Spring Boot compare to Ktor. And here in Ktor, for example, let's take a look at the run routes. This is how we would define such a get endpoint, for example, on Ktor, or such a post endpoint where we can post a specific run. So you can see this is already much more Kotlin-like, that we first of all define those routes, those HTTP endpoints here, via such a function that extends something. Extension functions are also a Kotlin feature. We can then inject certain classes, instances here via coin. That's something I will say something about in a moment. But then we can really have this typical Kotlin DSL-like syntax with these lambda functions here. We can say, okay, we want to actually authenticate all those requests we receive in here with our JWT authentication. The get endpoint to the /runs route would then simply take our run data source, get all runs for the current user ID, and here you can see we need to explicitly respond with a status code and optionally some data like our runs that we've retrieved for that user. So this is a bit different than like we had to do it with Spring Boot. With Spring Boot, we really work with functions. If those functions return something, then that is going to be taken as the response from Spring Boot. Well, here we need to explicitly call that respond with a specific status code and a piece of data. So this is one thing I want to compare these backend frameworks in. Another thing that they quite substantially differ in is dependency injection. So without going too much into detail what that is, dependency injection in the end just means we have certain dependencies. So we have classes that other classes may depend on, like this run data source here, for example, and we want to be able to inject those where we need them. So we want to be able to pass those around in our code base kind of. This is typically a very desired design pattern in software development. And here on Ktor, you can see this works via by inject. This is actually just an optional way of doing it. But here in this project, I'm using coin. So Kotlin inject, that is the probably the most popular Kotlin dependency injection library that we can also use on Android. And that lets us do things like this. So we have a central place, specifically here in DI app module, a central place where we just define our dependencies, so how these are created, like our MongoDB instance. And the moment we've created that, where we say, hey, we have a singleton here, then we can also inject those dependencies here with the by inject delegate. So this is important to mention. This coin library must explicitly be used here if you want to do it like this. Alternatively, you can of course still stick to dependency injection, but then you would need to manually pass all those dependencies around here just as function and class constructor arguments. Let's take a look at how this works like in Spring Boot. So here we have Spring Boot again, and we definitely also declare certain classes, which are directly also a dependency. And these classes also depend on other classes, so on other dependencies. And here in the constructor, we effectively perform dependency injection because we have some dependencies, and I'm actually not sure why I have the node repository twice here, so we should be able to remove one of them and then fix this issue very quickly here. Repository. Then here, where we pass the node repository to the node controller, we inject this dependency here into the node controller. So far, so good. If we take a further look here at what we have in the code base, We have a certain node repository, for example, which is a Mongo repository. We have certain models. These are not too important to open for dependency injection, but we have something like an auth service annotated with service, which provides functionality to register a user, to log in a user, and so on. But the interesting thing is, here on Spring Boot, you won't find a file or a class like we had on Ktor with this application module where we specify how our dependencies, how our classes have to be created. Because this is a very unique thing of Spring Boot, because Spring Boot comes with its own integrated DI framework. And the moment we launch our Spring Boot backend, it will figure out how to create all those classes and wire everything together on its own, unless it, of course, fails to do so. But thanks to all these annotations that we add here in Spring Boot with controller, the Mongo repository is also under the hood, a Spring Boot managed dependency, and all those dependencies we call beans in Spring Boot. And everything that is a bean is a class that is managed by Spring Boot and that we can freely pass around in our code. So this is super easy because it just works out of the box. We don't need to create any class instance on our own here in Spring Boot, and we can just reference these in the constructor, and it will just magically work. This is super cool and a breeze to work with. And even though I like Coin as a dependency injection library, point goes to Spring Boot. And the last thing that I want to take a look at least in the code itself before I share my personal experience. So definitely, if you have a backend framework, there are certain things you need to configure. For example, which routes are authenticated and which aren't. And here in Spring Boot, this works, for example, via this security config. So again, making use of annotations here in order to automatically create and pass this object around. So in Spring Boot, it's a very common pattern. We define some kind of class, we annotate it. This contains some kind of function, we annotate it. And this function is then just magically called at the right time here in the security filter chain, for example, where we can configure how we want to secure our backend. For example, here we have certain request matches. We say that the base route permits all requests, so that does not require authentication, and that all the routes in the auth endpoint here also don't require any authentication, since these routes are needed in order to get authentication details when registration happens. But everything after that here, any request that did not match the previous matches, that is authenticated. So just to share one example of how such server-based configuration works on Spring Boot, so just important to understand, makes use of these annotations, makes use of these filter chains. You maybe sometimes need to inherit from a specific class, like we did here in the JWT auth filter here. That's a once per request filter, which is also a class that comes from Spring Boot, which will then automatically just invoke this code for every single request, kind of like an interceptor. Taking a look at Ktor. In Ktor, we do have those so-called plugins that help us to configure our server. So a plugin is really just something that typically comes from its own library, from its own module in Ktor. And a single plugin is just something we can dynamically install at runtime in our Ktor project that we can then use to configure a very specific part of a backend. For example, security. So we have configure security. And here, for example, if we have this authentication block in which we can configure authentication. For example, here I have set up API key authentication, which is used if you actually bought the course to build this app for this backend. Then you will get an API key via email, and you will be able to connect to this backend. But of course, there needs to be some sort of authentication setup so that not anyone could connect to this server here just by having the IP address or the URL. Another type of a plugin that we could install in Ktor is this content negotiation plugin, for example. You also know these plugins from client-side, maybe if you've used Ktor client-side before. But content negotiation is in the end just defining the format how data is shared. So here in this example, data exchange works via JSON. And if we want Ktor to automatically parse requests from JSON and responses to JSON, then that works by installing this content negotiation plugin, saying, okay, this is the JSON parsing library of our choice. And here we can then configure that as well. So you can see in Ktor, we can also dynamically just install these plugins here at runtime. We have this typical Kotlin DSL syntax with these lambdas in order to configure a specific part of the server. Here, monitoring, for example. We can log every single request that comes in. We can define how these logs are like. So here, I think Ktor isn't necessarily easier, but also not necessarily more difficult than Spring Boot. It's just a different way to configure things. However, something to note is that in Spring Boot here, we just have a whole lot of more packages and such extensions that we can choose from when we even set up our Spring Boot project, since it's just a much more mature backend framework. So it makes sense that there are more extensions that we can pick from. So if we just create a new project, then select Spring Boot here. I don't know if we can choose that here, what this consists of. No, but they do have a web wizard where you can choose from a lot of packages that you want to pre-select here, which is this start.spring.io. In Ktor, we have something similar, but yeah, for Spring Boot backends, you just have a whole lot of more packages and just helpful extensions and SDKs you can choose from. All right, I think this gave you an impression of how these backends really compare on a code basis. What's now my personal experience? Because I've really worked with both types of backends. To be fair, I've worked a little bit more with Ktor than with Spring Boot, which is why I can also share a very frustrating issue with you that has happened to me lots and lots of times with Ktor before. And that is that I can't count how often it has happened to me that I just want to bump up a version on Ktor and I immediately get these, what is it called, no such method found exception or so. So your Ktor code tries to invoke a certain function, but that wasn't found because it's not included in the sources or so. Because the thing is on Ktor, if we take a look here again, that a lot of the libraries and tools you choose that Ktor is built on rely on the single Kotlin version. So here we have a typical build.gradle KTS file and a Gradle properties file where we have some versions. So you can see we have a Ktor version, we have a Kotlin version, we have a MongoDB version, we have a Coin version. And since on Ktor, we typically, or at least often, work with these pure Kotlin libraries, they depend on the actual Kotlin version much more than Java libraries. And what has now happened to me very often is that I, for example, saw, okay, new Ktor version is out. I bumped up my version to that new Ktor version, but doing so actually silently broke some code in MongoDB, in the Kotlin driver of my MongoDB implementation, or the Kotlin driver of an SQL client or so that you've attached, because that also relies on some kind of Kotlin version that may then not be compatible with Ktor, or Ktor works, but Coin requires a different Ktor version because Coin comes with its own Ktor-specific dependency that you have to apply in order to make this work. And just getting all those dependencies work together with the right version combination, this has been very frustrating to me in the past with Ktor. And while in Spring Boot certain libraries definitely also depend on a Kotlin version, these issues haven't happened to me yet. And I don't think these can't happen, but I think they are just definitely less likely going to happen, because we are typically not using the Kotlin drivers here for talking to a database instance. We are not relying on a library like Coin, which is another library that relies on a Kotlin version. Spring Boot itself is also not heavily dependent on the Kotlin version we choose, since it's again built on Java. So this is really just something where my backend often broke without me noticing that, because these no such method exceptions, they weren't just thrown when I launched this backend, which is something I would have immediately noticed. But just when a specific type of request was coming in that called a specific type of code that called this function that wasn't existing, and then it just silently failed in production. On the other hand, what I like about Ktor much more is that it's simply Kotlin first. I just like Kotlin more as a language, and I think most people do when they really start using Kotlin heavily. It's just better for things like syntactical sugar, for just a nicer development experience overall. But Spring Boot is also very cool because so much is already working out of the box. There are so many mature libraries, which is why I nowadays would write my new backend frameworks in Spring Boot with Kotlin for myself. But if I would rely on really finding many other developers who help me with the backend, or I would say, okay, I want to apply to a job or so, and I want to have the best possible job opportunities, then I would develop in Spring Boot with Java at this point, or choose another backend framework that's very popular, like I said, Node.js, a Python backend, maybe Go or so. If you are interested in these other types of backends, then definitely let me know that down below, and I'm happy to make videos about these too. And let me know in general as well how you like these occasional backend related videos. Because even though my channel is mainly about mobile development, about Android development specifically, having this backend knowledge really, really helps you as a mobile developer too, because so many apps out there just need to talk to a backend. And it just helps you in your daily work. Even if you just build mobile applications, if you understand how a backend also works, which status codes there are, how HTTP works, how WebSockets maybe work, that really helps you in the real world as a mobile developer too. Awesome. By the way, if you are a mobile developer, then until next Monday, Easter Monday, you can still get 25% discount on all my premium courses. You will find the link down below. The discount is already applied on checkout, so you really just need to go to checkout. It's applied. Happy learning, and you can get 25% on all these courses. Awesome. Then I will see you back in the next video. Have an amazing rest of your week. Bye bye.